Hello friends, our friends, I think you all are fine. So, welcome to our channel DK Education. So, today we are going to study about the diagram of spectral lines. We already studied in previous videos about spectral lines. So, in our syllabus only 5 spectral lines. So we study about that 5 spectral line by the diagram. Try to understand. So there are only 5. So first we have to draw the lines for them. So that is N6, N5, N4, 3, N2 or N1. So we have already studied about Lyman, Balmer, Paston and bracket and Pfund. So now we are going to draw the formula. We are going to draw the diagram for that. So that we take here Lyman series. Lyman series of line. Here Balmer, Paston, Lyman, Balmer, bracket. So that are in our syllabus. That 5 spectral lines are in our syllabus. That are the hydrogen emission spectral lines. So when electron jump from any orbit to first orbit, so first we have to take it at N2 to first, then it is Lyman series. When any electron jump from any orbit 2, 3, 4, 5, 6, 7, 8 in first orbit, then it is Lyman series. When it is jump from 2, that is also Lyman. 4, 4, 4, 5, 4, 6, and that here we take infinite, so that is infinite. So that is per line for Lyman series. So Lyman, that is for Lyman. When electron jump from third at second, then it Balmer. When third, fourth to second, fifth to second, and sixth to second, and infinite to second. That is for Balmer series. Or when it jumps from 5, 4 to third, 5 to third, 6 to third, and infinite to third. Then it is for Paston. Now for that is Lyman, Balmer, Paston, that is bracket. So when light jump from any orbit to fourth orbit, then it is bracket. When light jump from any orbit to fifth orbit, when electron jump from any orbit to fifth orbit, then it is Pfund. When electron jump from any orbit to fourth, then it is bracket. When an electron jump from any orbit to third, that is Paston. When electron jump from any orbit to second orbit, then it is Balmer. Bowman series is formed when electrons jump from any orbit to Lyman, then any orbit to first orbit, then it is Lyman. So that the diagram for the spectral lines which are in our syllabus. So that's the diagram. So now we do some numerical on that topic, and first we have to that is when electrons jump from higher orbit to any lower orbit. For Lyman, first we take for Lyman when electrons jump from infinite to first orbit. So we assume here at infinite the higher energy electron are present. So at infinite energy electron are present. At n1 lower energy electron are present. When we know that when any higher energy or higher value subtract from in a lower value, then we got a higher value. So here that is when higher energy electrons come from lower orbit, then it emit higher energy. So when energy is when energy is when energy is high, when energy is high, so lambda is there. So when n1 is equal to 1 for Lyman, we are taking here for Lyman, and n2 is infinite. So the energy is maximum and lambda is minimum. So lambda is minimum. Second case, when electrons come from n2 orbit to n1 orbit, that they both are lower orbit, so the emitted energy is very less, or I should say very minimum, very minimum, because there is no lower energy orbit are present as compared to n1 or n2. That when we increase the number of cells, then the energy orbit are increases, so that both are the lower energy orbit. So when electrons come from n to n1, then the emitted energy is very less. So E is minimum and lambda is maximum. So that is now we take for Lyman Palmer, same as it is in all the remaining four spectral lines. That's like Lyman. So just as similar as in both are. That is the concept in that.